I'm going to introduce a resistor that is a function of temperature. And I'm not going to give you all the information about it, just what you need, which is that at 25 degrees C, we'll just go back to the examples we used before, it has a resistance of 1 ohm. And at 30 degrees C, it has a resistance of 2 ohms. So this is a different resistor, right? We're going to put it in a hopefully it's clear, in a pink box here, right? This is a new kind of resistor. Up to now, these were all fixed resistors. What I'm going to suggest is just like when we had the voltage divider, right? We replaced a fixed resistor with a sensor. Let us do the same thing here, now that we're sort of comfortable with the Wheatstone bridge, all right? And I've set myself up for this very easily, okay? Because the first thing I'm going to do is I'm going to insert the resistor, the sensor here. So this one here, right, is now a function of temperature, right? This now is R of T. So this is this one, and all the rest are 1 ohm. And now watch how I set myself up. If the temperature is 25 degrees, then this will become 1 ohm, right? That's the concept we're familiar with, right? If this is 1 ohm, what is the voltage here? Right? I'll put a marker around our sensor, right? This is our sensor. But because we are at 25 degrees, it's all 1 ohm. And so we have a voltage out of 0 volt. So we're reading 0 volt at 25 degrees. All right. Now the temperature changes from 25 degrees to 30 degrees. So this resistance also changes, a concept we're familiar with when we talked about, right, voltage dividers. What is that? Oh, it's right here, right? Right? I set myself up, right? I set myself up here as well, where in this case, this here represents the 30-degree resistor. Now, what voltage am I measuring here? Now I'm measuring 1.7 volt. So at 25 degrees, I measured 0 volt. It's called when the bridge is in balance. And when the temperature went from 25 degrees to 30 degrees, because this side of the bridge started to do something, this voltage went from 0 to 30 degrees. Now, sorry, the voltage went from 0 to 1.7 volts. At this point, I'm explaining to you how to use sensors in a bridge. I still haven't shown you what's the trick. Wait for the trick, okay? The trick is coming. You have a change of heart, and you say, wait, I'm not going to put it here, right? Remove it and put back a fixed resistor. I'm instead going to take this and I'm going to put it here, right? So let's go to orange. And this is where now I have R of T. What happens, right? Right? And so, sorry, this is where I was, I confused myself so much that I reconfused myself, right, into what I wanted to do, all right? Let's see what happens. If we go back to 25 degrees, we have, remember, this is a fixed resistor now, please, right? 1 ohm, 1 ohm, 1 ohm, and at 25 degrees, it's at 1 ohm. So we're here, right? At 25 degrees, this is 0 volts because everything is 1 ohm. When the room warms up from 25 to 30 degrees, this goes to 2 ohms. So I have 1, 1, 1, 2. What is the voltage now? Oh, okay, I have it. I set myself up. Here it is. This is now the sensor at 30 degrees C. And the voltage has gone from 0 volts to 1.7 volts. Oh. So whether I had it here or whether I had it here, it's interesting, right? In both cases, as it changed, right? And you can see why it was important that I swapped the signs. All right. And now the grand finale. okay, you put a sensor here and a sensor here. There are two sensors. Is it possible? It is possible. You are given two sensors, right? Two resistors that are sensors, and you're given two fixed resistors, right? And you put them together, right? It would be like, like that, right? That's the network, and the battery goes along the outside. You could build it, right? You could build it. Now you can say, well, where are these sensors exactly? Well, as you know, these sensors don't actually, we talked about earlier about extending the wire, right? But these sensors don't have to be on the bridge. They can be over here just by running the wires. But let's first look at the performance. Well, that's this case right here, right? Here we have our 30 degrees R sub 3 and our 30 degrees R sub 2. Right? Okay. At 25 degrees, the one, because it's 1, right, at 25 degrees, right, and the 1. What is the voltage? Well, we're back to here. We're always here. This is where we start. But now the temperature goes up from 25 degrees to 30 degrees, and both, it's important, both these sensors sense it, right? So both these resistors go from 1 ohm to 2 ohm. And so the voltage goes from 0 to 3.4 volts. The change when the warming happened, instead of going from 0 to 1.7 volts, 0 to 1.7 volts, we now go from 0 to 3.4 volts. We have more voltage change when the measurand changes. And if you remember back a few classes, I told you that if you want to make a good instrument, that is the parameter that you need to be obsessed with. Obsessed, whatever, interested in, okay? So in this case, let's think about it another way. Let's go back to voltage divider, right, to show you why the voltage divider can't do this. Let's do this with a voltage divider, right? Let's walk through it quickly to see how the voltage divider would behave. With the same elements, right, with the same elements. The voltage divider, which I'm now going to put here as VA, all right, VA at 25 degrees C, VA, I'm going to do this quickly, is 5 volts. Why is it 5 volts? Because I have a 1 ohm, and maybe I didn't say it, this is also 1 ohm, so 10 volts, 1 ohm, right, it's 5 volts. At 30 degrees C, what is VA? Well, VA in this case will be 6.7 volts. Why? Because I have 1 ohm, and then I have 2 ohms. So the change in voltage when the temperature goes from 25 degrees to 30 degrees is equal to 1.7 volts. We've seen this number before, right? That's the number here. Yes?
Before, when we were talking about voltage division with one sensor, we had mentioned how there was noise and there were different things that needed to be calibrated.
Yes.
Adding an additional sensor, does that increase or decrease the noise?
It's a great question. So the question is, if we add another sensor, does it increase the noise? Because what I'm actually showing you here is that it increases the signal. This is the signal. And I want to emphasize, I never care about the actual voltage. You could say, well, here I have 5, and here I have 0, right? So that must be superior. We don't care about the actual voltage, right? I can get a huge battery and make something that always has 100 volts in it. It's not going to be a sensor. We care about the change in voltage, right? And a voltage divider, and you can also try, by the way, swapping these out, right? You're not going to get as much voltage change, right? It's going to be the same delta, right? As you do with a Wheatstone bridge, which has what's called 2 arms. I mean, all Wheatstone bridges have 4 arms, right? But we have sensors here on 2 of the arms. One is not interesting to me. One, you might as well have made a voltage divider, right? One, you might as well, only when you got 2 do you boost it. And so your question is, will that also double the noise? In principle, no. I mean, in reality, you know, there's always the devil's in the details, right? But in principle here, it seems like you're going to get double the benefit. And going back to the example of the jar, of how you would implement this, you would have now, to stick to this color scheme, 2 sensors. Here's one sensor with its cable. And here is the other sensor with its cable, right? And then here's your circuit. So you go like this, boom, boom. And now we want to be careful how we wire it in. We have our fixed here. Oops. Like this. And then here I'm going to leave a little spot to insert something. We have a fixed resistor here. And then here I'm going to leave a little spot to insert something, right? So this is R1. Hope this is legible here. Okay, I'm kind of squeezing it in here. This is R4. All right, I'm just trying to squeeze it in here, right? But here's our Wheatstone bridge, and I've left 2 connection points here and 2 connection points here. Connect these here, connect these here, right? So it goes back to the notion that our sensors can be off, and now there's cables coming in. So in this case, mine, there'll be 4, right? Be aware there's going to be 4 wires running inside that cable. There's going to be a cable with 4 wires in it, 2 thermistors sticking at the end, and then your circuit is a Wheatstone bridge. And if you make this, you will get double the voltage change of someone who just makes a voltage divider. Okay.